Hi guys, thanks for watching again. Today we're going to be focusing on our buttons. In our previous attempts we've used one output for every button, so that would mean in this case 5 outputs or inputs, it depends how you see it. But this time we're going to try to achieve to wire 5 buttons up to one analog input. So as you can see, it are the round ones. They're all connected together with some resistors and wire. We're going to be using this technique to reduce the amount of pins needed on our board so we can save some room for our rotary encoders. So let's get started. So what is it we need for this video? Well, at first we need our Arduino Leonardo in this case. 5 buttons. I only had 4 big ones, so I had to put in the little smaller one. 220R resistors. We're going to need a few of them, so just keep a set on hand. And we need some wires and cables, but you should have those lying around when you start playing with Arduinos. So let's first start looking at how our buttons actually work. So as we can see, we can press them, and they have 2 sides, left and right, and they have the other side as well, but it will just work from the left to right. So as you can see, if we press the button, the power will go from left to right, and if we don't press the button, no power will go through the connection at all. So that's the basic working of our buttons. So what we used to do on our toggle box is that we would directly read out every button's state. So we would just say, okay, but the red button will be connected to our board via port, in this case I've selected port 6. And if a connection is made, a signal is sent to 6, and our board will actually know that the signal of the button is pressed. Okay, so let's pick up where we left, right? I just wired up our button as we used to. This is the small ground wire I was looking for, but couldn't find. So let me plug this right in, and I'll show you what happens right now. So the power goes in, we press the button, a signal gets sent to the board, and we know the button is pressed. At least that's how we used to do it. We need to wire up the ground to the ground line, of course, and the power to the power line. Right now, in theory, it should work that if we program Arduino to read out pin 6, we would know when the button is pressed. And if we would like to have 5 buttons like we used to, we repeat the same process over and over for each pin. So right now we can read out pin 6, pin 7, and if we'd like, we could keep doing this for the last 3 buttons as well. But as you can see, our board is already filling up while we haven't put anything on it. That yeah, it's quite noteworthy. So we're gonna look at how to fix this. I'm gonna pull out all the wires so we can start with a clean slate. And we used to check that if a signal is coming through the wire, we're going to check the button is pressed. Okay, so right now we have the same wire, but how can we make sure that our board knows which button is pressed if we're only going to use one? Well, we're going to use the analog 0. That's where we put in our cable, and we connect it all the way to the last pin of the tiny little button on the top. So instead of seeing if a signal is flowing, we're going to actually measure how big of a signal is flowing through our wire to our board. Purely for visibility, I've moved the green wire to the bottom, but we'll move it back later on. So you can either keep it on top or do the same as me, whatever you'd like. So we're going to start by getting our resistors. It's important, well, not important, but we are going to use the 220R version. As we can see, we're going to bridge the gap between the power and the left pin of the red button. And with left pin, I mean, if you look at it from the right side, so that's the right side if you look from it, from the board its side. Now the next step is to connect the left pin with the left pin of the yellow button. With the same, not the same resistor, with a new resistor, but with the same strength resistor. Oh, the cable doesn't want to go in. It's a new board, so it's a bit stiff still. And we will just repeat the same process for the last 1, 2, 3. Right, we connected 1, so that's 3 buttons left. So we always connect horizontally the left pin to the left pin of the next button with a resistor. And I will show you in a second how this looks from a close-up, so you can actually see how they are connected. But, let me finish this up quickly because they're so small and easy to bend and stuff. It was easier if I just first put them in and I'll show you. And then the last one that will go to the tiny little button on top. And once again, you can use any button you like. The one I've used on my prototype are a bit sturdier. But the principle, they all work the same if you go for push buttons. And we need to put our resistor in the end. I think I made a mistake there. Yeah, I'm sorry. It's sometimes it's can be quite painful to get them in, but let's have a closer look, shall we? So as we can see, every left pin of the button is connected to the next pin via a resistor. And the resistors are eventually going back to the ground on our board. And as you can see, I've alternated a left and right placement of the resistors, so they actually had space to link them together. So that's our first step. In theory, when our power will flow from the first button of the first resistor to the last, it will degrade in strength. So that's the basic principle we're going to use for our reading of the value of our buttons. So in this case, if we place a power a connection with the power line in the back, and I always like to have some of those small cables lying around for in these use cases. And then we're going to use connect the right power line to the left side where our power is coming in. Here we go. So right now you can see that our power comes in from the board. It will go to the first line, go to the other side, connect to the little wire over here, and the power will run through all these resistors back to the ground. We can actually use this same principle on the other side to measure the strength of power that is coming out. So we've wired the right side up with resistors, or is it really wired when we only use resistors? But it doesn't matter. I'm gonna get some fresh green wire for this just to color match it with what I'm already using. And I'm gonna use these cables because once again, I can just cut them really short, and that will make it easier for you guys to see what is happening. Take out off a piece of the sleeving. Here we go. And this time we're gonna connect the right pin to the right pins. So the resistors were connected to the left, and the other side will be connected to the right, Because remember, the power will only go to the right side of the pins, or the left side if you look from this side, if the button is pushed. So if nothing is pushed, no signal will be sent through this cable and nothing will happen. And we will just repeat the same process for all the buttons. So after some fast forwarding, we've actually wired up the last wire. On the top, we've connected the green wire to our board. And as we can see, if we go to the power side, we have the resistors. And if we press the button, a signal will be sent to our A0 port. If we press the first button, one resistor is passed, as you can see. If we press the second button, two resistors are passed, 3, 4, and 5. And this is actually what we will use to determine which button is pressed, because the signal will weaken the further we go down the chain. There's only one thing that's missing currently, and that's the last resistor to our ground wire. And we need to connect the green wire to our ground line to the left. And this is because when we don't press a button, the green wire will be an open circuit in theory, because the end is connected to nothing. So if we connect it to our ground, our readings of 0, so no buttons pressed, will actually be more stable, and the readings of the values itself will also be more stable. So as you can see, it goes straight to the ground on our board. And that's the hardware part actually all finished up, and we can start looking at how to code up this board to already use in-game. So we are gonna start with a new sketch. So we're gonna start from scratch. Yeah, see what I did there? But the first thing we need is our old library that we've been using all this time, which is the HID project, which can be found on the sketch include library HID project, and it will include the files automatically. And as we remember, we have our void block and we have our loop block. So the loop block gets executed every time in a loop, and the setup block gets executed once. So what we've actually done is we've created a system where we've put a cable inside the A0 analog input. So we're going to start by defining that pin on our board. So we're going to say, let's say button, pin, I don't know, whatever you like. And it's going to be A0, because that's the port where we're going to read our values from. And as in our previous videos, we're going to start by starting our gamepad with not with a capital B, so like this. And we're going to start our serial monitor, serial.begin, at a rate of 6900, which I will explain in a later video, but for now it's not that important to know what exactly this means. So we have a gamepad set up and we have a serial monitor set up. And now we're going to do something in a loop. So the first thing we're going to do is we're going to actually check what the value is that's coming in through the A0 port. So we're going to say, we're going to create a new variable called temp, which is going to be a whole number. And we're going to say this value is analog read button pin. So in our case, we've called our button pin A0 button pin. So check what the value is via the analog input. Now you might say to yourself, okay, but how does this look? Well, we can actually already tell by just printing this value to our serial. monitor. If you would like to have one continuous line, you would just do print. But if you want a new line, you do ln at the end of line. So it will come in on every new line instead of one continuous spew of data. And we're going to put in a little delay, and that's because the data will keep coming and it will keep reading, and it can, you can just get lost in all the numbers, etc. So we can actually already upload this to our board. And if we now take a look at tools, and normally we've used the serial monitor, but we're going to use the serial plotter. Oh, I think I have the monitor open somewhere. As you can see, currently we don't see anything, but the moment we press our first button, you see a signal coming in. Now if you press the second button, it's a stronger signal. The third button, even stronger. Fourth button, fifth button. And as you can see, there's a bit of variance in the values that's come through. But in theory, they all can be distinguished by the amount of power that is coming in. And this is the concept we're going to be using. So we're going to close this one, but we are going to use the monitor. We can open it up here. And you see now we can actually just see the values that this board receives. It's going to be a bit easier to work with than a graph, but the other one was just for a visual representation of what is happening. So if we press the first button, we can see that it will be around 110, 112, 111. So we're going to do something with that information. First, we're going to see if something, we do what is in this block. So we're going to check if our value, so temp, is smaller than 100. So this is the smaller sign. And if you would want to have it bigger, you could do it like this, but we want small. So if it's smaller than 100, if it's 10, it's a false reading, etc. So we know then we don't want to do anything. No button is pressed, but we do want to do something else. So else if is just a starting point. And then we say else if, so only if this is not true, but this is true. So in this case, temp is smaller than, we've just saw that if you press the first button, it's 110, 112. So we're going to say if it's smaller than 120, we're going to do this. So if it isn't smaller than 100, check if it's smaller than 120. And if that's the case, we're actually going to do gamepad.press 1. We're going to write that to our system. We're going to tell it, okay, I've just pressed a button, save this state. And we're going to add in another delay. It's a bit bigger. I've noticed that when I press it, and I can be a bit clumsy, so that sometimes it gets registered twice because the delay was too short if you just have the 100. And that could cause the system to think you pressed it 3 times while you just been making one constant motion. And we can already test this. The only thing we need to add is gamepad.release all. Forgot the brackets. And we need to write that to our system. And why is that necessary? This block gets executed every time. This block checks, okay, if something happens, press this, press that. And we're going to release it if nothing happens. We could also place it over here, and it would be the same result. I think it would be actually better if we put it here. We'll see what happens if we upload our code. we go. So if we press the first button, we can see it knows that the button is pressed. And that's it. Now we could just as easily repeat this process for the second one. Yeah, a bit tidier. If we take a look at our monitor again, we'll see the second button is 144. So let's just say if it's 150, I'm gonna press 2. I'm gonna do the same for the next one, which will be 210. And I'm just picking a number that's somewhere around the area, but it isn't like the +1 because that gives us a bit too much error margins. So we're gonna put on like 10 or 20 extra. So in this case, 340, we're gonna pick 350. And I know the next button is anything else. Because we know that if it's not this one, it's the next one. Is it not the next one, etc. And then the only thing that's left could be the last button. So in this case, it will be button 1, 2, 3, 4, and 5. Now, as you've noticed, we've repeated ourselves several times. So we said gamepad press, right, delay. So what if we wanted to change the delay, we would have to do this 100, and then yeah, I need to change it here. Here, so that's not what we want. So we're going to create a new function. Ugh, I hate a word. So we're going to say void. It's not going to return anything. Press button. We're going to do something in this block. So if this block of code gets called, we return nothing, but we need an int called I, just a counter. And why is that? Because we want this to happen. So you want to say, okay, gamepad dot press 5, whatever, gamepad dot write, and a delay. But we want to know which button to press, because or else every time we call this block of code, button 5 gets pressed, but we don't want that. We want I to get pressed. So in this case, if we say over here, we go, I'm going to call the function, press button. We want it to press 5 in this case. The system will call this block of code, pass the parameter 5. This one will request the parameter 5. So it will be like, okay, I received the 5. And I'm going to press the same button that you've passed in my parameter. Write it, delay, and that's it. So now we can just, I'm going to copy this because I don't want to type it 5 times. So here we go. And we just keep that in to release the buttons. And we could go over this like 1, 2, 3, and 4, and 5. So it's the same result where we used to have this code 5 times, but it's tidier. And if we want to change something, we only have to do it in one spot. So let's just check if everything is still working. Oh, okay. 5, 4, 3, 2, and 1. So that's it. And you can already just bind these buttons to whatever game you'd like. It doesn't have to be Flight Sim. We're going to be making the radio with it. But if you would like it for Call of Duty, I don't know, whatever rocks your boat, it can be done. So if you have any further questions, let me know in the comments. I will get back to you. I'll see you next time. All the resources used in this video can be found in the description, and I'm currently working on creating a new of my own platform where I can share my content with you, so you don't have to look at several places for the codes and the stuff I've used in the videos. So if you have any questions, Let me know and have a nice day.